Good morning, dear students. Today we will discuss known parametric measures for measures of association, right? In our last two presentations, we have discussed parametric measures for measures of associations, and these were correlation and regression. We tried to check the association between two or more variables with the help of them. With the help of correlation, we check the association, and with the help of regression, we check the causation between the variables. When it comes to non-parametric associations, for measure of associations, we have got two methods which are majorly used. With one is Spearman rank correlation coefficient and another one is Candle-Stowe coefficient. Let us discuss these two tests one by one. Spearman rank correlation coefficient was given by British psychologist Charles Edward Spearman in 1904. That is why it is named as Spearman rank correlation test. And when we talk about non-parametric test, that means we are either talking about nominal or ordinal data, right? Here we are talking about the ranking data, ordinal data. That is why we are calling this particular test as rank correlation coefficient. So Spearman from the name, and then rank because ranking data is there, and correlation coefficient because we are checking the association, measure of association. It is a non-parametric measure of correlation. In normal correlation, when we were discussing it with the help of Pearson's correlation coefficient, it was parametric measure of correlation, and Spearman rank correlation coefficient is your non-parametric measure of correlation. It assesses how well an arbitrary monotonic function could describe the relationship between two variables without making any assumptions about the frequency distribution of the variables. When it comes to Pearson's correlation coefficient, we check the normality of data. We try to check what kind of the frequency distribution is there for those variables, right? But when it comes to Spearman rank correlation test, we do not check anything. We will just be taking the data and would be conducting the test. It is useful basically when quantitative measure of certain factors cannot be fixed. Sometimes we cannot calculate data in quantitative values, right? But the individuals in the group can be assigned a rank. Whenever we are talking about the ranking data, you will be and we want to check measure of association, then these methods are there. And Spearman rank correlation test is the most widely used tool for correlation. Then Spearman rank order correlation coefficient is given by basically this formula. This is Spearman's rho, which is equal to 1 minus 6 into summation of di square, which is the difference between two brands. We'll be discussing it with the help of example as well, so as to know the formula in a better way. Divided by n into n square minus 1. N is the number of observations here. There are basically two things, n and d. D is the difference between two rankings, and n is the number of observations. We'll just discuss it with the help of an example. And the value of this particular coefficient, rho coefficient, lies between +1 to -1. It is just the same as in Pearson's correlation test. In that also, we assume the value of correlation coefficient between +1 to -1, and it is just that if the value is -1, these are perfectly negatively correlated. If the value is +1, that means two variables are perfectly positively correlated. If the value is somewhere between or somewhere around 0, that means they have if the value is exact 0, that means there is no correlation. If value is above 0.7, that means they are highly correlated. The variables are highly correlated. If the value is around 0.3 or less than that, then that means they are low. They are showing low correlation among them. If the value is around 0.5, then that means there is a moderate correlation among the variables. And if the value is positive, that means variables are positively correlated to each other. And if the value is negative, that means the variables are negatively correlated to each other as per the value will be checking how much they are related, how much they are associated, and with plus and minus sign we will check whether they are positively or negatively correlated. So let us have a look at this example. Two managers are asked to rank a group of employees in order of potential for eventually becoming top managers. The rankings here are these rankings are basically for these 10 employees: A, B, C, D, E, F, G, H, I, J. That means N here is 10. Ranking by manager 1 is this. He has ranked manager A, employee A as 10, B as 2, C as 1. This way he has ranked all 10 employees, and the same employees were ranked by manager 2 as well, right? So we will be checking whether these are correlated with whether their ranking is correlated with each other or not, right? So what we'll be doing is we will be taking up the difference between these two rankings. For example, for employee A, ranking by manager 1 is 10 and ranking by manager 2 is 9. So the difference is 10 minus 9 equals to 1. So we'll be checking all the differences like this, and then we'll be squaring it like this. Ranking by manager 1 is this and ranking by manager 2 is this. You can see D is equal to R1 minus R2, or it can be like R2 minus R1, vice versa as well, right? So because minus sign doesn't matter here, we are just going to square this value. So it is like, even if you do not notice the sign here, positive or negative, it's okay. So if your value is 10 and 9, that means 10 minus 9 is equal to 1, 2 minus 4 is equal to minus 2, 1 minus 2 is equal to minus 1. For D, it is 4 minus 3 equals to 1. For E, it is 3 minus 1 equals to 2. For F, it is 6 minus 5 equals to 1. For G, it is 5 minus 6 equal to minus 1. For H, it is 8 minus 8 equals to 0, because the same ranking. I also has the same ranking, so it is 0. J has the ranking of 9 by manager 1 and 10 by manager 2. So 9 minus 10 is again minus 1. So we'll be squaring these values now, because in the formula we are going to take di square. That means every difference ka square and then the summation. So here it is, 1 is 1, 1 square is 1, 2 square is 4, 1 square again 1, 1, 4, 1, 1, 0, 0 and 1. Total comes out to be 14. So D square has a value of 14 and N has a value of 10. So now by putting these two values in the formulas, you can easily calculate the value for rho, right? So when you put values like this, 6 into 14 for di square divided by 10 into 10 square minus 1. So value would somewhere be somewhere like between 84 divided by 990. So that means it would be somehow correlated. So it would be highly correlated value, because even here you can see the values are, the differences are very less. There are 10 employees. Ranking of 10 employees means they could have the difference of 9 at the maximum. 10 minus 1, that is 9, but they have the difference of 0, 1 and 2 only. That means these would be highly correlated with their ranking by manager 1 and ranking by manager 2 is highly correlated, right? Then one more example is there. For example, calculate the rank correlation coefficient for the following data, where the marks of two tests given to candidates for a clerical job. Preliminary test, they got the marks like this, and in final test, they got such marks, right? So these are also like ranking by manager 1 and ranking by manager 2. When you calculate the difference, you'll be ranking these marks like from 1 to 10, and again you will be ranking these final test marks as well, and now you will be checking the difference. 10 minus 9 is equal to 1, 9 minus 7 is equal to 2. This way you have taken up all the differences. Now you will be squaring these values. 1 square is equal to 1, 2 square is 4, 2 values again 4, 3 square would be 9, then 2 is 4, for 3 it's 9, for 1 it's 1, for minus 2 it's 4. You'll be summing up this. it is 44 now, right? And n is equal to 10. Again, going back to the same formula, you can put the values here. 6 into 44 divided by 10 into 10 square minus 1, right? So the value is somewhere between moderately correlated, right? You can see it with the help of this as well. You can see that 1, 2, and up to 3 differences there, right? So it is not exactly highly correlated, but it is correlated. So we can put it as a moderate correlation. One more example in which we can see one little more difference. In examination of 8 applicants for a clerical post was taken by a firm and compute the rank coefficient of correlation. Uh, these are the marks in accountancy and these are in statistics for all these applicants. You'll be giving them the rank now for accountancy and then in statistics. Yes, this is also important when two candidates have the same marks. So you will be summing up their rank and you'll take the average. For example, they were both were at the third rank, that means third and fourth rank. So you will be taking the average of 3 plus 4 divided by 2 and it is coming out to be 3.5. So you will be assigning 3.5 rank to both the candidates, right? Now you'll be checking the difference and you can see that we have very high differences as well. That means and more the value of d square you find, more would less would be correlation, right? Because it is getting minus from 1 and it would be, it is one of the examples of low correlation, and you can actually judge it by this value of d as well, right? Because here we are getting the difference of 4 and 6 as well when the total number is n. So this is showing the high difference. That means they are very low correlated with each other. Its advantages are it is very simple to understand and it's easy to apply. And it is used especially when the data are of qualitative nature. It is the only method for measuring correlation based on the rank, right? And then its disadvantages are this method cannot be used for grouped frequency distribution. For example, sometimes grouped frequency is also provided. For that, it is not done, and it cannot be used if n exceeds 30 and ranks are not given. Either ranks are not given or n is exceeding 30, then it is not possible. That means for a very large number of data, it is not very useful. Let us discuss the other method, Kendall-Tau rank correlation coefficient. It was given by Morris Kendall in 1938. And it is almost similar, like you have given the brand A, B, C, D and their group by group 1, their they have been ranked by group 1 and group 2 as well. So you'll be checking the consistency now. Group 1 has ranked brand A as 3 and group 2 has also ranked the brand A as 3. That means there is a consistency. That's right? Then brand B has been given rank by group 1 as 4 and group 2 has recognized it as in the ranking of 1. That means there is a negative change, right? So you'll be taking it as a -1. C shows for brand C, group 1 says its rank is second and group 2 has given the ranking of 4. That means it is a positive change and you'll be giving it as +1. Again for D as well, it is 1 for rank 1 for group 1 and rank 2 for group 2. That means again a +1, +1 and 1 -1. That means total +1. So you will be calculating that value on the basis. You can even rearrange it like this, or you can go ahead with this particular table as well. And this is the formula for checking degree of consistency. That is n divided by 2 is equal to n summation of n divided by 2 multiplied by n minus 2, and P would be the actual total score divided by n by 2. So this is how you'll be calculating this degree of consistency for Kendall cows. This is not very much used an analysis, you can say, because most of the times we go for Spearman correlation test or Pearson's. But in some of the studies, when you have given very less values, like you have put 4 brands only and 2 groups are actually telling you the ranks, then you can go with this. For larger values, for large sample size, it is not used. It is used for very small sample sizes. That's it. Let us discuss some self-assessment questions now. Number 1, define known parametric test for measure of associations. Explain with the help of an example. What are the known parametric tests of measure of associations? We have just discussed 2 tests, and these are the you can just list them down and explain them with the help of example. You can take the same examples, you can just put put a column for employees, then their ranking by 2 managers, and then you calculate that with the help of formula. You can actually calculate row and tell it like whether it was an example of low correlation, moderate, or high correlation, right? And in the same way, you can calculate Kendall-Tau's coefficient as well for 3 or 4 brands, like we have just discussed in the presentation. Then second is list down the steps to perform Spearman rank correlation coefficient test. Why it is used? You can actually list down all the steps, like you have to mention the table of ranking first. For example, if you are already given the ranks, then that reduces 1 step for you. But otherwise, if ranks are not given for any score, any kind of score, you will be first ranking both the both the values, both the variables. First step is ranking of both the variables. Then second would be checking their differences one by one for all the values. Then after checking the differences, third step would be calculating d square, that is square of all the differences, and then you will be summing all the values of d square, and then you will be calculating n in the end. You have the value for n and d square now, so you can calculate rho. Rho is equal to 1 minus summation of d square, right, divided by n into n square minus 1. You will be putting up all the values for d square and n. Now you can calculate the value for rho. And then when you have got the value for rho in your hand, now you can decide whether the variables are positively correlated, negatively correlated, or with the help of magnitude, you can say whether they are there is low correlation, moderate correlation, or high correlation among the variables. That can be explained with the help of the table we have already done. Like if rho value is above 0.7, that means high correlation is there among the variables. And if value is less than 0.3, that means very low correlation is there among the variables. And if the value is around 0.6, or you can say somewhere between 0.3 or 0.4 to 0.6, that means moderate correlation is there among the variables. These are the steps. And why it is used? It is used basically for the ranking data. When you have ranked the variables, and when you have data of ranking the variables, and you want to check the measure of association between 2 variables, then it would be used, right? If you do not have the ranking data, then you can go with if you have that, I mean, if you have interval or ratio scale data, then you can go with Pearson's rank correlation, Pearson's correlation. Last is, when do we use Kendall-Tau test? Explain the procedure. Again, with the when it comes to the ranking data for different brands, and when we have very small size of sample, then we'll be using Kendall-Tau test. Explain the procedure. Again, almost same procedure is there as like Spearman rank. You'll be explaining the formula, and you'll be just listing down all the values of variable 1 and variable 2. Then you'll be checking their ranks, and you'll be the difference of ranks. If there is no difference, that means zero value is assigned. If there is a positive change, you will be assigning value of +1, and if there is a negative change, you will be assigning the value of -1. Like Spearman rank correlation coefficient, we get to know that how much difference is there. But in case of Kendall tau, we just mention +1 and -1 for the difference, right? So that is the difference. That would not tell you the exact correlation among the variables. Spearman rank correlation coefficient test would tell you the correlation among the variables in a better way than Kendall tau test. So Spearman rank correlation test is most widely used correlation rank test. That's it. Thank you. And in our next presentation, we'll be using multivariate analysis. Till now, initially in this unit, we discussed descriptive analysis first. That was just to describe the variables or describe the population. Then we discussed univariate analysis. Univariate analysis means using one variable at the time of analysis, right? You might be having multiple 10, 20, 50 variables in the study, but you are basically analyzing one variable at a time. That is univariate analysis. When you were using two variables at a time, it was bivariate analysis. When you are using more than two variables at one time, that means three or more than three, that would be taken as multivariate analysis. So in our next presentation, we'll be discussing all the multivariate analysis available to us. Multivariate analysis would consist of some of the analysis which we have discussed in univariate and bivariate as well. But the thing is, it would just change the formula for variables, because there are more variables than one or two, right? So the same tests are also there, but we'll be having some more tests as well. For example, first one is when it comes to multivariate analysis, first one to discuss is correlation and regression. We have already discussed them in case of bivariate analysis. So we'll be just having a look at them in case of multivariate setting, and then we'll go ahead with other analysis, other you can say other tools, other analysis available for the data analysis. That's it. Thank you.